Module 6, Data Communication, Delivery, Information Anywhere and Anytime. We live in a world of instant delivery of information. You can communicate with almost anyone, anywhere in the world, instantaneously. And this is going into the business world at ever increasing rates. Specifically, during and post-COVID, we're seeing more and more remote working, more and more online collaboration. Why do managers need to know about data communication? We can ask this about anything we've talked about so far. Why do managers need to know about the nuts and bolts of databases? Why do they need to know about different parts of a computer? As a manager, you need to have enhanced decision-making effectiveness. If you know a little bit about the lingo of whatever processes we're talking about, you can make better decisions. I've said this before and I'll say it again. Nothing derails a meeting quicker than having to stop and define what we're talking about. The meeting just loses momentum and you're not as productive. Any manager involved in meetings like this, even up to the VP level, need to be able to speak relatively informed about a variety of topics. You don't need to be an expert about it. That's why we hire people to be experts for us. But you need to be able to speak in a well-rounded manner about everything. And for this module, we're going to be going over data communications. Like we said before, because of the internet, because of the technology, things are becoming more accessible and easier. Now, more than ever before, we're doing more and more online training, vice having to bring in outside organizations or individuals to conduct on-site training. It's cheaper, it's more effective, and honestly, we get better quality training from that because it's not always possible to bring in that subject matter expert into your office and do hands-on training. It's much easier to do it online. With that, web and video conferencing is easier, and it goes without saying, searching the internet for information keeps employees up to date. It is so much easier to Google information, look up information that before would have taken days or even weeks to find source documentation. If you know anybody that does coding for a living or computer science majors who go into code, we always joke that modern coding is just copying and pasting somebody else's code. For better or worse, that does run into some issues with lines of code that aren't necessary and bog things down. But this goes across the board, even outside of coding. It is so easy to have quick references because of the internet. I was in a conference call today and a question brought up that nobody knew the answer to. So we took a quick little time up. We all Googled it and we had some information and some source documentation within a few minutes that we were able to make better informed decisions from. Having a good foundation for each one of these topics allows us to make better decisions, and it allows us to speak with our subject matter experts in a more intelligent way that really produces good cooperation between management and those, quote unquote, on the floor. So let's get into some basic concepts here. You've probably heard bandwidth before. Anytime we're signing up for internet for personal use, we always want to make sure that it has good bandwidth. Sometimes we don't understand what that means. Basically, that's the amount of data that can be transferred from one point to another over a certain period of time. And that's from your device, your laptop, your iPad, your cell phone, to the server that you're getting it from your website through your ISP. Obviously, you want to do that quickly and with a lot of data. Anytime we are transmitting data, whether it's wired or wireless, there is a potential of signal loss. That's just physics. You're going to lose some of that energy as it travels. That's called attenuation. And finally, broadband. That's multiple pieces of data are sent simultaneously. It's very broad. We don't hear too much anymore narrowband. This is your voice grade transmission. It goes over POTS, P-O-T-S, plain old telephone system. That's your hardwired phone, maybe at your parents' or sometimes your grandparents' phone, depending upon your age. When I was growing up, this is how we went on the internet. We used narrowband on a 56K modem. That was the only way of connecting to the internet. It was very low speed, very low bandwidth, and there's only limited things you can do with it. But that's what we had at the time. And there are still some parts of the world where narrowband dial-up is their only access to the internet. As with anything, there are protocols, and there are protocols for data communication. And these are the rules that govern your communication. How do we detect errors? What do we do with those errors? How long can your messages be? How long can these packs of bits, these zeros and ones, be packed together in a packet to send? And what is your transmission speed based on hardware, software, and infrastructure going into it? Some people incorrectly think that modems are only for dial-up. Really, they're just a device that connects a user or a device to the internet. Modem is short for modulator demodulator. It's not required for all internet connections, but it is pretty much a staple, and it is used for the majority of them. Like we talked about, it does cover dial-up connections. This is for an analog modem, and what we're doing in dial-up, we're converting sounds to digital signals. Like I said, it uses ordinary phone lines. Sometimes you'll hear this as POTS, plain old telephone system. It is rarely used today in most developed nations, but there's even still parts of North America that have dial-up, especially your very rural areas, as their only means of internet connection. DSL, digital subscriber line, is a high-speed service that also uses POTS. Similar to dial-up, it uses sounds, but it uses it at a much higher frequency, and that's what drives the higher speeds. If you ever interacted with a DSL system in a home, you'll know that you have DSL filters, and these plug in between the phone that you use to speak with and the rest of your lines, and that filter removes that high frequency noise that your computer and your DSL modem needs to communicate to the internet. And finally, we have cable modems. This is probably the most popular, or at least widespread access to the internet. It uses normal coaxial cable that you get your TV from, and it's mostly very high speed. In a lot of cases, it's higher speed than most DSL providers can even touch. Cable modem is by far probably one of the best residential options we have out there. If we have a network, we need to have a NIC, network interface card. This is your Ethernet card. Sometimes you'll see them with BNC connections for industrial applications. This is a hardware card that enables your computer to communicate over the network. You'll sometimes hear it as an adapter card, but there's different forms of it, but NIC is common. Most operating systems will refer to it as a network interface card. In our OSI model, this is the physical and data link is where the NIC lives at. Types of networks that the NIC can connect you to is your LAN, WAN, and MANs. Your LAN, your local area network. These are what you'll find in an office building. This is kind of what we have at St. Francis. Local computers, workstations, maybe some servers will connect that are close in proximity. WAN, not wireless, but wide area network. This goes over several states, several cities, and it's owned by different parties, mostly large organizations, sometimes state and federal governments. Similar to that, but on a little larger scale, is Metropolitan Area Network, your MAN. This handles the data communication for multiple organizations in and around large cities. Let's talk a little bit about the topologies of these networks. It's easy to think that wired and even wireless networks are just all connected to some sort of switch and that's the end of it. But there are planned out topologies, and these are things that we need to consider when we are building a network from scratch or revamping a network. And a lot of times the decision kind of goes down to how much money do we want to spend and how much reliability do we want to sacrifice. Anytime we're talking about large networks, the more money you spend, the more reliable it will be. But usually we have to come to a compromise somewhere in the middle. We can't spend too much, but we also have to have a certain degree of reliability. This leads into the star topology. we were to draw this, do a line diagram, it looks just like a star. You have a central computer and a series of nodes. Cable layout is super easy. You centralize control, you know exactly where it's going, and we can diagnose problems very easy in a star topology. We can quickly add other devices onto it, but if the central host fails, the entire network goes down. Cost increases as we add more nodes on it. So, and adding more nodes adds more cables, so it does become more expensive. Ring topology just looks like a ring. It's a big circle. There is no host computer, but each node is connected by an upstream and a downstream neighbor. Transmission is in one direction. It needs less cabling than the star topology that we talked about before, but diagnosing problems are more difficult. Looking back 15, 20 years, ring topology was very common in a lot of Apple central networks. All the computers would talk to each other. They would handle all the up and downstream neighbors. And like I said, transmission was in one direction. So it was very easy, in my opinion, to add more nodes on it. But if there was an issue, you really didn't know where it was. Sometimes we would joke that it's kind of like the old, Christmas tree lights. If one goes out, they all go out, and it's kind of hard to figure out exactly where the problem is. Mesh, every unit is connected to every other unit. You'll sometimes hear this as plex, multiplex, or interconnected. Very, very highly reliable. You can have a couple units go offline, and it won't affect operation at all. And obviously, the larger your network is, the more units can go offline without any disruption of the connection. This is very expensive and difficult to maintain, but if you want a very reliable network and you have the means, which most large companies do, mesh is probably your way to go. These 5 topics on the page here, protocols, TCP/IP, routers, routing, and client and server model, this could be its own lecture itself, and for a comp sci class, this would be many, many weeks of different discussions and articles. But for this class, we're going to look at a very 30,000-foot view. Like I said before, I don't expect you to become experts at each one of these topics, but I do want you to understand the base definitions for them. Like anything, we have protocols, and for a network to work, every system needs to be quote-unquote speaking the same language. There are wireless and wired protocols that all hardware devices have to adhere to even operate on the network. This allows networks to work efficiently. All of the packets need to be sent in a certain manner and in a certain way for the network to function. So we have different protocols, and these vary on the networks, and sometimes they're network specific. But this is how we maintain order on our networks. TCP/IP, Transmission Control Protocol, Internet Protocol. This is an industry standard communication protocol that enables interoperability between every device that connects to the internet. From your laptop to Internet of Things devices, they all adhere to TCP/IP. This is in the transport layer of the OSI model, and this is what establishes the links between hosts. I really can't emphasize how important TCP/IP is for really just the internet to function. This really regulates how packets are sent and received and even acknowledged on any network. It's really the backbone of any network, and probably something that people don't understand exists or may not understand how important it is. On the network layer of the OSI model, this is where our routers live, and these really control traffic flow on a network. They choose the path for information to go through, and it is varied on a bunch of things. We want to make sure that it gets there as quickly and efficiently as possible without delays, because even on networks, you can have quote-unquote traffic jams. Think of this as a highway. You have many different ways to get point A to point B, and depending on how traffic is flowing, how accidents, maybe there's a server down, how can we get that packet of information, that delivery truck from point A to point B as quickly and efficiently as possible based on what it is. We have static and dynamic routers. Static routers really just give different addresses. This is what you are. Dynamic routers build these tables and they identify addresses on each network. We see more dynamic routers being commercially available now that will automatically build IP tables. Before, in the dark ages of networking, somebody had to assign a static IP address. If you didn't keep track of this, then you might assign the same static IP address to another device on the network. You would have a conflict, and all kinds of issues would arise from that. But the dynamic routers take care of that, and they do all of that automatically for us. What would our world be without wireless networks? Well, we wouldn't have cell phones anymore. Tablet computers would be almost useless, and really even laptops. What's the point of a laptop if you have to be plugged in all the time? Well, there was a time where we had laptops and you had to be plugged in all the time. We didn't have wireless built into it. A laptop is really just for portability, not using as portable. Your wireless networks are two different aspects here. They replace your wired technology, the Cat5, the fiber optic cables, or even the BNC cables that would run through an industrial office. But we also have mobile networks, and that is for your cellular devices. Similar protocols for each. It's transmitting data wirelessly. Attenuation is a big factor anytime we have wireless transmission. Wireless networks are typically lower cost than their wired counterparts, extremely flexible and easy to install, but you have a limited range. And I'm sure even as you walk through even your home, apartment building, or office, there are certain areas where you do not get signal for your cell phone. Even on a wireless internet connection, I know there are places in my house that I just can't get Wi-Fi. That's just the way it is. It's hard for signals to penetrate through some of the walls, especially brick walls. So there are disadvantages to it, but I think the biggest thing is the security. In the 90s, war driving was really big, WAR driving. And the idea was you would sit in a car, drive through a network, maybe park outside an office building or somebody's house, and you would sniff, quote unquote, sniff packets from the wireless network, and that was how you could steal information from companies or individuals. That's very difficult to do with a wired network because you'd have to be inside the building plugged into the network. But for a wireless network, you can eavesdrop on that network anywhere you can connect to it. In some large office buildings, you can even get a decent signal outside in the parking lot with commercial off-the-shelf equipment. If you cater that equipment to be very good at detecting wireless at long ranges, you can not even be anywhere that they would detect you visually from the building to get a connection to their Wi-Fi and start packet sniffing. The final wireless technology and the last slide we're going to talk about is Bluetooth. Bluetooth really revolutionized the way that devices connect to each other. It's really meant for short connections, 30 feet or less. Sometimes you can get up to 50, but that's really, really pushing it. It's great for headphones. It's great for transferring data between cell phones and laptops. You can create a personal area network. This is, if you have all your Bluetooth devices, your keyboards, digital cameras, headsets, laptops, everything communicates itself on this network you set up. Again, small distances, usually inside a personal office, but it's very convenient for setting these up, and it's very easy too. Even compared to wireless networks or wired networks, Bluetooth, it's almost push to connect. It is that easy and simple to use. But there are security concerns with Bluetooth. As with any network, you really do need to think, do I need to transmit this data, this sensitive data, from one device to another? Do I need to do it wirelessly, or can I transmit it via a USB stick or over a wire connection to ensure the data is safe and I don't lose integrity of that data in the transfer? We talked about a lot of things here. And again, this is very glossed over a lot of these deeper topics. If the book doesn't do a good enough job explaining them in depth, please reach out to me. These are things that we can talk about for hours on end. But for the scope of this class, you just need to have a good basic grasp of each one of these concepts. As always, if you have any questions, please reach out to me.